students. This is Professor Karishma Gangude. I welcome you all in our next lecture of the estimating and costing, which will be from Unit 5, Estimate for Civil Engineering Works. In previous lecture, we have discussed the computing, what is earthwork computation, uh, how to find sectional area, how to determine the quantity of the earthwork, okay, and discuss few formulas, okay. Now in this lecture we are going to discuss the methods uh, methods that will be that will be used to determine the earthwork, okay. Here are the four methods as we have discussed earlier also. Mid sectional area method, mean sectional area method, prismoidal formula method, trapezoidal formula method. So in mid sectional area method, let's start with this. Mid-sectional area, in name itself, we get the actual idea of the topic. What we require to find out the quantity? We require mean area of the mid-section. Okay. So how to find? Let's discuss it. What we need to find out the quantity? We need area of the mid-section and length. Okay. Multiply by both the terms. We will get the quantity required for the earth. Okay. So let's D1 and D2 be the height of the bank at two ends. Like in this figure I have shown. Here are the two different depths, D1 and D2. Okay. So D1 and D2 at the height of the bank at two ends, that portion of end portion of embankment, and L will be the length of the section. So B and D, here is the B the formation width, and S as to 1 is your side slope. So in this case, how to find area of midsection? Area of midsection is equal to area of rectangular portion, that is this part, plus area of true triangular portion. This we derived actually before, okay. But what we have to add, this dm, what we need, mean depth, to find out the the area of the midsection, that is bdm plus 2 into 1 half into sd square. Okay, that is 1 half into sd square. This is 1 half into sd square into d. Okay, so that will be your this area of your both triangular portion. This is your rectangular portion, d into d. But d, what we require, d into, that is mid depth I need required to find out the to find out the quantity by mid sectional area method. As we get the mean depth, we will get the mean area. By using this area and multiplying with L, I will get the quantity of earthwork. Simple. Okay. This is your mean depth, dm. Okay. The quantity may be calculated in tabular form. So this is your format where we have to put all the quantities and calculate. That is chainage for the particular station. Okay. Then depth. What will be your depth at that chainage? That is depth of the formation level. That is your, like this depth. Okay. Then mean depth. Then area of central portion. This area. Okay. What happened? This cross section varies at various longitudinal slopes. So in this way, sectional area always changes. So for that, what we do, we find out the mid sectional area. So for that, we require area of central portion, area of sides, total sectional area, length between station. Okay, that if we consider 10, 20, 30, so that between so we require the length between that two stations. Okay, now, and last we need to calculate the quantity from these values. Okay, bd plus sd square into l. If it will be get positive, we have to embankment, we need to do embankment, and if it will be negative, we have to cut that part. Simple. Okay, cut that much quantity in for that road or for that cross section, okay, to form the particular formation level. So this is the first method, mid sectional area method. Now another method, so in this another method is area of side sloping surface. Okay, area of sides may be required turfing or pitching, as we know that. Okay, in water resource engineering we have discussed the turfing and pitching. Okay, may be found by multiplying the mean sloping breadth by the length. The mean sloping breadth, it will be under root of SD square plus D square. Always remember, an area of both side slopes equal to twice L, that is twice the length, into D under root of S square plus 1. So this may be calculated also in the tabular form. Firstly, we have to add the change of the particular point, then depth or height, then mean depth, then put the values in this formula. With side slope, we will get sloping breadth. Then length between stations. Okay, that is the difference between the two stations. Difference of length between the two stations. Now total area of both sides, so that is twice L D under root of S square plus 1. So this we will get total area of both sides slopes. This now let's talk about the mean sectional area method. In mean sectional area, we need the mean area, likewise the mean depth. Okay. In this method, what we do, we calculate average cross section of both. Okay. In mid section, what we compute each and every mid section of the embankment. Here, what we do, average of the two ends of the section. Okay. And then mean of this two is multiply the length of the section to depict the volume of the earthwork. Okay. Now let's see, at one end area will be BD plus ST square. Okay, for this particular part area will be A1 is equal to BD SD1 square. Okay, here area at another will be A2 is equal to BD square BD2 plus SD2 square. Okay, here is a D2 is will be the height, or we can say depth. To find out the mean sectional area, what we require, we have to find out the mean. Simply a1 plus a2 by 2, I will get the mean area, and d1 and d2 are the heights or depth at the two ends. So quantity will be mean area into length. That's it. So we can calculate from the tabular format also. This is your tabular format. Station change in first column, in another column depth or height, that is we can say d. Here is we need to find mean depth, then area of central rectangular portion, then area of side triangles. Here we have to put total area. Here we have to find out length, and we need to calculate lastly quantity by this formula. So this is the mean sectional area method. Okay. Mean sectional area method and mean sectional area method are both having difference. Always remember this. Remaining methods to compute the quantity of the earthwork we will discuss in our next lecture. Okay. Thank you so much.